Right, let's have a look at, quickly review what we did yesterday. When you've been given an inverse trig function, it could be written arctan and tan with a -1 up there. That's the same thing, they're both inverses. Whenever you have an inverse trig function, your answer is going to be an angle. We're looking for an angle. Inverse cosine, arc cos is the same as inverse cosine. Inverse cosine, we're looking for an angle. And what we have to remember is that there's a restricted range of angles that come out of these. This first question is asking us what angle has a tangent of -1. It's as though we're being asked for, told the tangent of our angle is -1, and we have to find that angle, but the angle is going to be restricted to just either the top half or the right half of the circle, where the top half of the circle goes for angles from 0 to pi, the right half of the circle, and you don't look in quadrants 3 or 4, you're only in quadrants 1 or 2. The right half of the circle, you don't look in quadrants 2 or 3, and you go up to pi over 2 and you come down to -pi over 2. So that's like it's quadrant 1 and the reflection of quadrant 1 down into quadrant 4. So how to know whether you're looking at the top half or the right half of the circle is you can do this quickly. Cos, sine, that tells you cosine's in the top half, sine's in the right half. Cot goes with tan, tangent, you look in the right half, cotangent, you look in the top half. And secant goes with cosecant. Secant is between 0 and pi, and cosecant is from -pi over 2 to +pi over 2, the right half. Okay, so when we're looking for the angle whose tangent is -1, tangent is in the right half. So we're looking for an angle in quadrant 1, or the reflection of quadrant 1 down to -1. And what we have been told is the ratio. We know that we don't know the angle, but we do know the ratio, so make that be a ratio. And for tangent, the ratio, these two lengths we've been given are y and x. If it's negative, we're not in quadrant 1. Things in quadrant 1 are positive. So we know that we've got this is not quadrantal, this is a triangle, this is a 45, 45, 90 triangle, because the legs are the same length. So I'm looking at this angle here. If I filled those x and y dimensions in, the x is 1 and the y is -1, and if I needed it, the r would be the square root of 2. But I don't really need it. All I'm looking for is the angle that created it, just this angle here. It's -45 degrees, -pi/4. Our next question, again, it's an inverse tangent, so again, we're going to be looking at the right half. Again, it's negative, so we've got some triangle somewhere with an angle somewhere between 0 and -pi/2. And what I know about it is I know that the tangent of the angle is negative the square root of 3. Turn that into a ratio. That is the ratio of a y divided by an x. If my x is 1 and my y is -√3, that's a 30, 60, 90, where my reference angle here is the 60 degrees. It's opposite the long leg. So that is -pi/3. And the third question here, inverse cosine. You look up here, cosine is the top half. The range of my answers are going to be somewhere between 0 and pi. The angle I'm looking at is somewhere between 0 and pi. And what I know about it is I've been told the cosine of my angle is that ratio, √3/2. And if I've been given a cosine, that ratio is the size x divided by an r. So that's part of a 30, 60, 90 triangle, where the x is the long leg So the y would be the short leg. I'm at that angle there. Root 3, 1, 2, that angle there. It's opposite the short leg, which is 30 degrees in radians. That's pi by 6. And my fourth question, I'm being asked for the inverse cosine. Inverse cosines are in the top half, somewhere between 0 and pi. And I know the cosine of my angle is negative square root of 3 over 2. If the cosine is negative, the angle is still positive, but I know it's in quadrant 2. I know the x must be negative. X is negative root 3, r is 2. This is my angle here. The angle is positive. That is a 30-degree reference angle, which is pi by 6. So this angle is, the angle that's written here is 5 pi by 6. My angle is, I haven't got room to write it there. Beta is 5 pi by 6. So that was a quick review of yesterday's lesson. Try some more. Let's do some more difficult ones where we're trying to hide it, trying to make it look more difficult. So here's 6 more. Pause your video, give this a go if you're watching this by video. Choose at least 3 of them. Okay. So let's just remind ourselves how these go together. Secant goes with cosecant, cos goes with tan, cos goes with sine. So when I see cosecant, inverse cosecant, I know I'm looking at the right half. I know that my cosecant of my angle is, oh, let's give myself more room to write this. I know the cosecant of the angle is negative 2 root 3 over 3. That has come from negative 2 over the square root of 3, where the square root of 3 in the denominator has been rationalized. It's much easier in this format to recognize what your triangle is. If we're being asked for an angle, we know it's based on a 30, 60, 90 if it's one of the green ones. I mean, 30, 60, 90 or 45, 45, 90 if it's one of the angles defined by these green points. Or if it's on one of the axes, it's quadrantal, based on 90 degrees. So cosecant is r divided by y. It's negative, so it's not in quadrant 1. The y is the long leg of a 30, 60, 90, so we're opposite the 60 degrees. That's 1 there, negative root 3 there, 2 there. That's opposite 60 degrees. This one, my angle I'm being asked for. This angle coming down here is the angle negative 60 degrees, which in radians, we always want stuff in radians, is negative pi by 3. Inverse secant, we're looking in the top half, it's negative. We know that the secant of our angle is, we've been given it's negative 1, we know that's a ratio, and secants are a ratio of r divided by x. It's not the r that's negative, it's the x that's negative. And we know we can see this one's quadrantal, because the length of the x is the same as the radius. So we're not going to be drawing a triangle, it's quadrantal, and we know that our x must be negative 1. It's the absolute value of the x, a equals r. So where on this have we got a point where the x is negative 1? Here. And the angle that's defining is pi. For this one, arc cosecant is negative 2. Cosecants, we're looking at the right half. It's negative. We're not in quadrant 1, it would be positive. We know the cosecant of our angle is a ratio of r divided by y, and we've been told it's negative 2. It's not the r that's negative, it must be the y. and that y must be -1. So that's part of a 30, 60, 90 triangle where the y is -1, the x would be the square root of 3. So that angle there in degrees is -30 degrees. We want this in radians, so it's going to be -pi/6. What about doing this one? Let's do them in order. Cotangent, cotan, top half, negative, not in quadrant 1, in quadrant 2. I know the cotangent of my angle is negative the square root of 3/3, which would be much nicer if we wrote it as -1 over the square root of 3, unrationalize that denominator. Cotangent is the ratio of x divided by y. Which one is negative when I'm in quadrant 2? Must be x. X is -1, y is the square root of 3. That's a 30, 60, 90 triangle. I want the angle. The angle that's created that triangle. This angle here must be 60 degrees. It's something to do with pi/3. In quadrant 2, that is 2pi/3. The angle is not negative. Our angle is somewhere between 0 and pi. It's positive. So only when you're going down that your angle is negative. Cotangent of the square root of 3, inverse cotangent. Square root of 3 again, we're looking in the top half. We know that the cotangent of our angle is an x divided by y, and it equals the square root of 3. Turn that into a ratio. It's positive. We're in quadrant 1 this time. Our x is the square root of 3. Our y is 1. So that is the angle 30 degrees, pi/6. And the last one on this page, inverse sine, is looking at the right-hand side. It's positive, so we're somewhere in quadrant 1. We know the sine of our angle equals 2. Turn that into a ratio, and we know that the sine is the y divided by the r. And we just think, how could I have a y of length 2 if my radius was only 1? That's impossible. This does not exist. When you think about it, on a sine wave, sine only goes from -1 to +1. There's no angle in the world whose sine, where does that intersect with the line 2? It doesn't. It does not exist. Right, what we're going to be doing today is we're actually going to be composing different inverse trig functions. But before we do, let's have a look at what happens when you compose functions. Could you solve this problem without a calculator? No way can I do that. But what happens if I made it a more complicated problem? What happens if I asked you to solve the square root of 2,576 squared? I made it more complicated, and suddenly you can solve it. Because squaring and square roots are inverses of each other. They cancel each other out, and my answer is going to be 2,576. So if I had written this as a composition of functions where f of x is the square root of x, g of x is x squared, if I do the composed function g of f of x, I'm asking you to solve that. It's really simple. So even though we couldn't find the square root of x, we could find the square root of x squared. We can do it composed. That's because inverse functions, when they're composed, they cancel each other out. Will this always happen? Will a function and its inverse always cancel each other out? No, not when there are restrictions on the inverse function. Where the inverse function can only give you certain values, it might not be able to give you back what you started with. So let's have a look at this. The inverse cosine of the cosine of pi by 4. Your temptation is to say, well, these are inverses of each other, they cancel each other out. My answer is pi by 4. And in this case, yay, you'd be right. But if you did it in this case, no, it does not equal 5 pi by 4. Okay? Why? So look at what's going on here. If we did this, we're going to do this in 2 steps. Let's do the cosine of 5 pi by 4. The answer we get, oh, that's not 5 pi by 4, the answer is, yeah, the question says pi by 4. So we do the cosine of pi by 4, get an answer, and put that answer into the inverse cosine of, and see what comes out. And we're going to see if the answer is going to be an angle, and hopefully it's going to be pi by 4. Okay, let's try this. So the first thing we're going to do is the cosine of pi by 4. How we evaluate that, we draw the terminal ray for pi by 4, turn it into a triangle. We know that's based on a reference angle of 45 degrees, so 1 square root of 2. Cosine is the ratio of an x divided by your r, so it's 1 over the square root of 2. And we normally go ahead and we rationalize that denominator. But to be honest, today we're going to prefer that answer. It's much easier to work with. Now, so that's what this evaluates to. Now we're going to find the inverse cosine of that. And that's going to give me an angle. So how I do an inverse cosine, I say inverse cosines are restricted to the top half. It's positive, it's going to be somewhere in quadrant 1. And I know I've been given an x and r. 1 square root of 2. That's a 45, 45, 90. The angle I'm looking for there is 45 degrees, which is pi by 4. So, step 1, I solved the inside. I got the answer from step 1, and in step 2, I did this outer function. And it took me back to where I started from, because the inverse cosine did cancel the cosine. But that's not always going to happen. Let's try this one. We do the inside. Sine of 5 pi by 4 equals a ratio of a y divided by an r. So draw your angle. 5 pi by 4 is here. Now can you immediately see the problem? When we do the inverse sine of something, we're only going to be looking in quadrants 1 and -1, bottom there, quadrant 4. This cannot be an answer for that. Okay? Let's have a look. So what does the sine of 5 pi over 4 give us? That's a 45, 45, 90. In quadrant 3, both the x and the y would be negative. My sine of 5 pi over 4 would be, my y is -1 over the square root of 2. Just leave it like that. Don't rationalize it. I mean, on a test, we'd want you to finish off with that, if that was the full question. But that's just a part-way answer, and it's actually better in that format. So now we get this, and we put it in here. So we're looking at the inverse sine of -1 over root 2. So I'm not going to be looking in quadrant 1, I must be looking down here. And I know that the sine of this angle I'm looking for is -1 over the square root of 2, where that's my y and that's my r. My y must be -1, my r is the square root of 2. This is my angle here, which is -45 degrees or -pi by 4. So in this case, the inverse function did not cancel out the original function because the inverse function was incapable of giving me an answer in quadrant 3. It could only give me an answer in quadrant 1 or quadrant 4. It could only give me an answer somewhere between negative pi by 2 and positive pi by 2. That's the range of the answers of inverse sine, and that's not within the range. Yes. Question, the third question here is very different. We've been given on the inside, let's do the inner part first. We're doing the inverse cosine of negative 5 pi by 9. Now I know that answer is going to be an angle. And I'm looking at it straight away and going into a little panic. I know inverse cosine only looks in quadrants 1 and 2. It's going to give me an angle somewhere between 0 and pi. And I know that the cosine of my angle is negative 5 pi over 9, which must be a ratio of an x divided by an r. And I don't know this triangle. This is not a triangle I know, where the x is negative 5 and the r is 9. That's this angle here. I don't know it. It's not a special angle. Mild panic. Not an angle we know. However, what's the question really asking me for? It's just asking me for the sine of this angle. Yeah? All I need to do is give the sine of that angle. I don't know the angle, but I do know this triangle that defines it. I can find the sine of that angle. All I need to know to find the sine of an angle is a y divided by the r. I know the r is 9. All I have to do is find this y dimension. And I can find that using the Pythagorean theorem. X squared plus y squared equals r squared. I know my x is negative 5. Square that, you get 25. I know my r is 9, so r squared is 81. So y squared is 81 minus 25, which equals 56. So y will be the square root of 56. Does that reduce? Yes, it can be divided by 4. That's square root of 4 times the square root of 4 goes into 56. 14 times. So my y is 2 times the square root of 14. And that's my answer. I found the sine of some random angle I didn't really know. Never found out what the angle was. I knew it was bigger than 90 degrees and less than 180. But I was able to find the sine of it even though I didn't know the angle. When we're asking you a problem where on the outside there's an inverse trig function, that was just a regular trig function. When there's an inverse trig function on the outside, your answer is going to be an angle. That's going to have to be an angle that you know, either because it's quadrantal or because it's part of a 30, 60, 90 triangle or a 45, 45, 90 triangle. So let's have a look at these. When the inverse function is on the outside, we've got an inverse function and a regular function. A regular function and an inverse function, a regular function and an inverse function. When the inverse function is on the outside, our answer is going to be a special angle, and it's probably not the angle you were given in the question, so you're probably going to need 2 graphs. However, when the inverse function is on the inside, that triangle you draw is going to define the angle that you're finding the outer function of. So you only need 1 drawing for those. Okay, let's try this then. Will they cancel each other out? Think about where 4 pi by 3 is. No. Inverse cotangent cannot give me the answer 4 pi by 3. So my answer is going to be something else. So let's do the inside first. The cotangent of 4 pi by 3 is simply going to be an x divided by a y defined by this terminal ray that represents the angle 4 pi by 3. And so this reference angle must be 60 degrees. It's based on pi by 3. So this is your long leg, negative square root of 3, negative 1, 2. My cotangent is negative 1 divided by negative the square root of 3. I'm just going to call that 1 over the square root of 3. I'm not going to rationalize into that. That would be making too much work for myself. Don't do that. Just leave it unrationalized. So that was the inside. I can replace the cotangent of 4 pi by 3 when I see it with 1 over the square root of 3. So now put that information into this question. I want the inverse cotangent. Remember, arc cot means inverse cotangent of this value we found. And that's going to give me an angle. And if it's an inverse cotangent, is that top half or right half? That's top half. And I've been given a positive ratio, so it's not in quadrant 2. Positive values would be here, negative values would be here. So I'm going to draw a second picture. That was my first picture that helped me with the inside. Now I'm going to draw a second picture that's going to help me with the outside. I'm in this quadrant. I know that the cotangent of my angle is a ratio, and this is an x and this is a y. So my x is 1, my y is the square root of 3. So that's a 60-degree angle. That's a 30, 60, 90 triangle there. So my answer is pi by 3. 60 degrees, pi by 3. Go all the way back up the top, put that up here. My answer is pi by 3. Notice that the function and the inverse did not cancel each other out. My answer was not 4 pi by 3. It couldn't have been, because 4 pi by 3 is quadrant 3, and the answer to none of these is in quadrant 3. Let's try the next one. Well, that's definitely not a special triangle. I'm just looking at those numbers straight away and thinking, I'm not going to know that angle. Let's do this. We can still draw a triangle that will define it, though. Arctan. That's telling us the inverse tangent of negative 1/4 is going to define my angle. Inverse tangent is in the right half. If it's negative, I'm looking at the tangent of an angle being negative 1/4 y over x. If it's negative, it must be down here. It's not in quadrant 1. I know the y is negative 1. The x must be positive 4. I don't know the angle. This is the angle here. I don't know it. But what I'm being asked for is the cosine of this. That picture is sufficient to define theta for me. To find the cosine of the angle, all I need is an x divided by an r. Now I know the x is 4. All I have to do is find r. And I know that x squared plus y squared equals r squared. So 16 plus 1 equals r squared. My r is going to be the square root of 17. That's my final answer, but when it's my final answer, you can't leave it like that. We're going to have to rationalize that denominator. So my answer for this one is going to be 4 times the square root of 17 divided by 17. Again, they're totally different functions. I'm going to have to do this in 2 steps. Let's do the inside first. So we're being asked, the inside is saying inverse secant. Inverse secant of negative 2 over the square root of 3 is going to equal an angle. Do I know this angle? I hope so, because I'm going to have to find the sine of it. Let's think. Inverse secant is top half. If it's negative, we're talking about something in quadrant 2. If it's positive, it would be in quadrant 1. Which two sides have I been given? I know the secant of my angle is negative 2 over the square root. Oh, nice. They could have been mean. They could have given us that as to that. If you see this, that is the same as negative 2 over the square root of 3. This was kind to give it to you looking like that. We could have given it to you like this and tried to confuse you. Yup, 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 yup. And for this, we were being kind to you with that one. So that is the ratio of r divided by x. I know my x must be the thing that's negative because it's not my r. The r is going to be positive 2. The x must be negative the square root of 3. Look at that triangle. That's definitely a 30, 60, 90, where this angle is 30. It's opposite the 1. So the actual angle I'm looking at here, the angle to this terminal ray, if this is 30 degrees, this must be the angle 5 pi by 6. Okay? Now we're being asked to find the sine of 5 pi by 6. We don't need to draw another triangle, we've already got it. This is the angle 5 pi by 6. To find the sine, I just need the ratio of sine is y divided by r, and I've got that. Here's my y, here's my r. Oh, that was nice and easy. 1/2. The 5 pi by 6 was a sort of halfway answer. Notice we didn't have an inverse on the outside. That's why we got away with only drawing one picture there. The last part of the lesson is really the graphs, and why we want the graphs is sometimes we ask you questions like this. Give me the range of the inverse sine. Give me the domain of the inverse sine. You can do a lot of it just by doing those little crossword puzzle sort of setups. Or you can look at this. We restrict the domain of the sine from negative pi over 2 to positive pi over 2. We restrict the domain from negative pi over 2 included to positive pi over 2. That restricted domain becomes the range of the inverse sine. And the range there would be from negative pi over 2 to positive pi over 2. Remember, you switch domain and range. And this one's range, the y values go from negative 1 to positive 1. They would become the domain of the inverse sine. Remember that question we had at the beginning that said, what's the inverse sine of 2? And the answer was D and E, because look at this. Inverse sine is only defined for inputs. The inputs can only be between negative 1 and 1. That's why the answer on that one doesn't exist. Let's have a quick look at the graph. You don't need to be able to reproduce the graph itself, but let's have a look at it. We're going from this point here to this point here through the origin. This was the point negative pi over 2, negative 1. On the inverse, you switch those around. It will go from negative 1 on the x-axis, negative pi over 2 on the y-axis. So we've got this point here, and then this upper point here is the point, the x value is pi over 2, the y value is 1. That will become the point on this graph, 1 pi over 2. So we need to go from 1 on the x-axis to pi over 2, positive pi over 2 up here. This is what the graph actually looks like. And for cosine, we're going from a restricted domain of 0 to pi. It's got a range still of going from -1 up to +1. If I draw the points I'm going to draw for that first point is at 0 for the angle 1. And those switch round. On this graph, I'm going to draw 1, 0. So 1 across, 0 up. Oh, what am I drawing it there for? It won't be there. It would be here. Then I'm going to draw to this point here, which is that pi on the x-axis, -1 on the y-axis. That will become the point -1 pi. So I'm going to go to -1 over here and pi up here. So there. How am I going to draw those points? Let's think about this point in the middle. That's at pi over 2 going across, 0 up. That's going to become the point 0 pi over 2. So when I'm at 0 here, I'm at pi over 2 there. So this graph actually goes like that. And the range of the inverse cosine function, the range is going from 0 to pi, which was the same as the domain and range switch. And this one's domain is going to be possible inputs are the same as the range from the actual cosine. How would that work with a secant and cosecant? Well, I'm not going to do them both, but if you turn this graph, the cosine can be turned into the graph of the cosecant by putting an asymptote through that midpoint. The high points give you a half a smile, that will give you half of a frown. So the range, the angles, the output for an inverse secant r divided by x would be going in, the range coming out, the angles are still going to go from 0 to pi, but they're going to have this asymptote at pi over 2. When you see that written out, it goes 0, pi over 2 has to be excluded because there's an asymptote there. This still goes up to pi. Okay. This one, the domain is restricted from -pi over 2 to +pi over 2. This is the tangent. That's the restricted domain, which will become the range, the y values. And this one's range goes all the way down, all the way up. It's going from -infinity to +infinity. That will become the domain. It's going from -infinity to +infinity. That's the way the graph looks. Remember, a quick way to remember all of these is that top half, right half stuff. Remember, cosine and sine are the simplest ones. They just go, for instance, from 0 to pi, or from -pi over 2 to +pi over 2 included. They're quite similar to the secant and cosecant. These also have the same included endpoints, but these ones have got an asymptote in the middle, where you're excluding the mid value. This one you'd be excluding the mid value. There's an asymptote there. And then for tangent, doesn't go across the top, does it? Cotangent and tangent. They're quite simple to write out, but remember to exclude those ends because there's these asymptotes here. This one's at pi and at 0. That would have been the graph for the cotangent. Cotangents inverse cotangent range of angles, the answers that can come out go from 0 excluded to pi excluded. For inverse tangent, the angles go from negative pi over 2 to positive pi over 2. I find it easier to just think of them as the top half and the right half. That'll do for this lesson. Please do your homework. You have a quiz tomorrow.